video for today is factoring trinomials when a is greater than 1. So when we have a trinomial in standard form, this number here, a, is going to be greater than 1. There's a few methods to factor when a is more than 1. I'm going to show you one of them. And the method that I like to use is Jaime-Escalante's method. Jaime-Escalante's method, you have three simple steps. Keep in mind that you do have the terms or the variables a, the b, and the c. Make sure you really know which numbers represent a, b, and c. Because for step number 1, you have to know to multiply a times c. So you have to look for those numbers. So when you multiply a times c, first number times the last number, you're going to get a negative number, you might get a positive number. So you're going to get some number. And then you find two factors that will multiply to that number and be combined to get the b value. So you multiply a times c, find two factors that multiply to this number and can be combined, you add or subtract to get the b value. Make step number 2, you make two fractions and reduce. Now the fractions are here. So the first fraction is going to be the value of a divided by the first factor you found when you multiply a and c. The second fraction is going to be the value of a again divided by the second factor. And I do have some numbers here with arrows because notice that I named this number 1, I named this number 2, number 3, and number 4 because instead of number 3, you're going to write two parentheses, so the product of two binomials, and this is how you set up your answer. First, make sure you use the variable that's in the trinomial. So if we have x, you use x. If you have p, you use p, whatever variable you have. The number before x is going to be number 1, and I'm looking at the first parenthesis. The number after the x is going to be number 2. So whatever number here you have, it goes in front of the x. The number in the bottom goes after the x. For the second parenthesis, you're going to use number 3 before the x and number 4 after the x. So you can think of it like this. You have the numbers vertically in the fraction, so up, down. All you want to do is move those numbers, arrange those numbers horizontally, sideways. So you have 1 on the top, 2 on the bottom, 1 on the left, 2 on the right, 3 on the top, 4 on the bottom, 3 on the left, 4 on the right. So let's try a couple or a few examples here. I do want to start with the difference of two cubes, and difference of two squares and perfect square trinomial. So before we actually use Jaime-Escalante's method, you can factor this type of special polynomials. Yes, you can use Jaime-Escalante's method, but when you have difference of two squares, you don't have to use Jaime-Escalante's because we know that all you have to do is use the square root of the perfect square numbers. So for example, this one here, we have 9x squared minus 16. Well, first you're going to set up your two binomials, so the product of two binomials. You're going to take the square root of 9 and the square root of 16. Now notice that a is not 1, it's more than 1. So I need to take the square root of a and the square root of c. So the square root of 9 is 3, so you put a 3 there, 3 over here. We need an x and an x because when you multiply this, you are going to get 9x squared back. So 3x times 3x is 9x squared. The square root of 16, that's 4. So you put 4 and 4. And since we have a minus in the middle, we need a negative and a positive over here. So these are your factors. For number 2, you want to factor, we have a perfect square trinomial, and you know that because a is a perfect square number, c is a perfect square number, and you have a plus for c. If you have a minus for c, that's not a perfect square trinomial. So all you do, guys, you need to have your two binomials. You take the square root of 9, which is 3. You guys are going to take the square root of 4, which is 2. You take the square root of 2 here, and you're always going to use the sign in the middle. So you put it here and over here, and remember to keep the variable that you see in the trinomial. So remember to keep the variable that you have in the trinomial. It's a good idea to always check if you get the number in the middle or the term in the middle. So to check, you can multiply using not the whole FOIL method, but you can multiply the inner terms. So negative 2 times 3x, that's negative 6x. Multiply the outer terms. So 3x times negative 2, that's negative 6x. Combine the two terms here, and that's negative 12x. Sometimes the trinomials, they do look like a perfect square trinomial, but when you multiply the inner and the outer, you do not get the middle term. So it's a good idea to check. Now one more step when you have a perfect square trinomial. If you notice the binomials, the parentheses, they are equal. 3x minus 2, 3x minus 2. So when that happens, you can actually write it down. Your answer, you can write it down as a binomial squared because you have two equal parentheses, and the parentheses are 3x minus 2. So we have a binomial squared. Now let's go ahead and use Jaime Escalante's method on this one because we do not have perfect square numbers. It's not a perfect square trinomial. So the first step, okay, so number 1, you multiply a times c. So we have 5 times 6, which is 30. You find two factors that multiply to 30, two numbers, and they also combine to the middle number. And in this case, I know 15 times 2 is 30. And look at the numbers when you add 15 plus 2, that's 17. But we do want a negative 17. So we have to make this one negative and this one negative. When you multiply those two, negative times negative, it's going to be positive 30. And when you combine the two numbers, you get negative 17. So that's your B value right there. So that's the first step, right? This is my factor number 1, and this is my factor number 2. For my second step, I'm going to make my two fractions. So the first fraction is going to be a, which is negative 15, divided by b, by first factor. Oops, hold on guys, a is not 15, that's your first factor. So a is 5, so you take a, 5, divided by the first factor, which is negative 15. You have to reduce the fraction, so this turns into a 1 over negative 3. Now you see the negative on the bottom. Jaime Escalante's method says that you have to keep the negative on the bottom because you'll see in a little bit in step number 3 why we need it on the bottom. So this is my first fraction reduced. Second fraction is a again, so 5 divided by second factor, which is negative 2. So you cannot reduce the fraction, so here we have the second fraction. So step number 3, you're going to have your two parentheses. The first parenthesis is going to represent the first fraction. So this is number 1, this is number 2. So number 1 is in front of the x, so 1x. Number 2 is after the x. Now remember that negative? So negative 3, so you're going to put minus, you carry the negative 3. If you put the negative to the side of the fraction, usually that's what we do in math. When it's on the side, you don't know if the negative's on the top or the bottom, so keep it on the bottom so you know it's after the x. This is number 3, so you put it before the x. This is number 4, so you put it after the x. So these are your factors using Jaime Escalante's method. So let's try a couple more. So here we also have a times c. So 6 times negative 3, that's negative 18. You want to multiply or find two numbers and multiply to negative 18. and that's going to be 9 times 2. And you guys notice that we have a positive here, so that means the biggest number is going to be positive. So this is negative. We need one negative number to get negative 18. So when you multiply, you do get negative 18. When you combine 9 minus 2, that is 7, which is the b value. So step number 2, you get the value of a, which is 6, divided by the first factor. So that's going to be 9. Reduce the fraction. That's going to be 2 over 3. So here's my first fraction. Then you take a again over negative 2, which is your second factor. Reduce, which is 3 over negative 1. So reduce by 2. So step number 3, you have your 2 parentheses here. So the 2 is in front of the x, 3 is after the x, and is positive, so plus 3. This one before the x, this one after the x. So we got our 2 binomials. And let's try one more, guys. This one I want to try with you guys because notice a is not 1, but we do have a negative in front of the a, and it says GCF. Usually they don't tell you guys when you factor that you do have a GCF, so you have to look for it. Sometimes you can factor a GCF. So this one here, notice that first let's take out the negative. So negative, it's outside of the parentheses. And when you look at the coefficients, the numbers 18, 9, and 27, the greatest common factor is 9. So you take out a 9. You might say it's 3 the greatest common factor. Well, 3 is a common factor, but it's not the greatest one. 9 is bigger than 3. So when you take out the 9, first, when you take out the negative, you need to change the signs. So you're going to change the signs. When you take out the 9, 9 goes into 18 2 times, so you put 2 and squared. Change the sign. 9 goes into 9 one time, so you're just going to have n. Change the sign. 9 goes into 27 3 times. Right? So every time you factor, it's a good idea to check if you can factor out the greatest common factor before you actually use Jaime-Escalante's method. So now you are going to factor what's inside of the trinomial, okay, or the parentheses. So here's the new a, new b, and new c. So you multiply a times c. So here's step number 1. 2 times negative 3, which is negative 6. Two numbers that multiply to this number and give you the middle term. That's going to be negative 3 and 2. So you get negative 1 when you combine. So that's the b value. Second factor, you make your two fractions. So you take the value, which is this one, value of a. 2 divided by the first factor cannot be reduced. And then you take the value of a again, divided by the second factor. You can reduce 1 over 1. Don't make it a whole number. I know 1 over 1 equals 1, but keep it as a fraction because you need to know what number goes in front of the x and what number goes after the x. So step number 3, here's your first parentheses. So this number is before the x, this number is after the x. Over here, this number is before the x, this number is after the x. You might have a question, do you need this x in front of this 1 in front of the x? No, you don't need it. You can erase it. You do need this 1 after the x though. Right, guys? So I'll see you guys next time.